Hey guys, today we talk about the benefits of co-creation, but in the developer sense, so mainly mob and pair programming. And my guest studied this topic extensively, is currently principal engineer over at HelloFresh, Dragan Stepanović. Don't forget to follow us and subscribe on YouTube, and follow us on your favorite podcast platform. Enjoy!
Of successful people in IT. From your sponsors, Zebia, creating digital leaders. Here's your host, Patrick Akil.
Hey Dragan, how's it going?
It's going good. Thanks for having me.
Yeah, man. Thanks for coming on. It's another remote episode, and I'm looking only at a camera. Normally I would see you, but we had some technical issues. But I think the recording will turn out fine. So thanks for coming on. Where are you located exactly?
So I'm located in Berlin.
Awesome. Cool.
Yeah.
So we invited you on to talk about, it's going to be a comparison about co-creation and kind of asynchronous work. And I think when we say asynchronous work, the main thing we mean is a developer puts up a piece of code for review, someone reviews it, and that goes back and forth a bit until you actually deliver the value that was in that pull request. But first and foremost, why are you passionate about this topic? Where did it come from? Because you've done some research, I saw in your background. But where did that come from?
Yeah. So my background is been a long time already since I've been part of the XP community, and the way that XP kind of prefers in terms of the ways of working is usually these very short feedback loops. If we look at the extreme programming practices, stage-driven development, pair programming, etc., continuous integration, right? So the idea is very short feedback loops, face-to-face communication, and all of that. Yep. And but I've been part of the environments and organizations and teams that have been working in a different way. And I think actually most of the industry currently is working in a bit different way, so to say.
Yeah.
Pull requests being one of the very prevalent ways of working. And since I advise and coach the teams in terms of trying to figure out the ways of maximizing the throughput of the value through the team, right?
Yeah.
Some of the mechanisms that I tend to look at is how the teams are working. And I've been having lots of these conversations around, like which ones of these should we prefer or try to experiment with. And there hasn't been any data, at least I haven't found any data that is related to this topic. So at one point I was curious to understand, in a data-informed way, how does the world in the async work looks like?
Yeah.
And the reason for that was I tend to have this principle of meeting people where they are. So, if you're working this way, okay, that's fine. Let's try to figure out, what's the effect of that, or try to visualize the workflow. And it started really as the study itself started really as a lightweight idea coming from this background, right? But then as I started digging into thousands and thousands of pull requests from the repositories that were very active in the typical product development teams, right? Not open source mode of working, I got to see some systemic insights that both I expected and some systemic insights that I didn't expect at all.
Interesting.
So that was really kind of interesting part that this study kind of provided for me, at least.
What did you expect on that study to see?
So some of the questions that I tend to get as we work in the async pull request way, or async code reviews through pull requests, is that, yes, we as industry know that, or finally know, which is a really great thing to see, that big pull requests are not something that we would like to have, right? So we know this from, developers have been feeling this pain for a very long time. If you have a pull request of 1,000 lines of code and you get it for a review, most likely you're going to, get +1s, looks good to me, thumbs up, just push it through, because, the cost of review is really huge. The cognitive load, the amount of time allocation that I have to have in order to do a review, back and forths, because there's so much code there that has been changed. Then the authors also tend to have, as you invest your time in the work, it also brings this emotional attachment to the work. So there's lots of sunk cost fallacy in there. So it's really hard to course correct in any possible way once you get a really huge pull request, right? So the system incentive in this way was that, just let it pass, and sometime, most likely never, we're going to go back and rework the things that we did, right? So that's the thing that I expected, like seeing really low engagement on big pull requests. That was something that I kind of expected, the thing they saw. But the thing that I didn't expect is that, okay, now as industry, we figure out the small pull requests are better than bigger pull requests. Why? Because it demands less time allocation from reviewers. There's less of sunk cost fallacy bias. There's also, we're able to course correct sooner. Which means that we are able to converge to a solution that we all agree on sooner. And this is actually a story about small batches from Lean, because all of this body of knowledge is coming from Lean. That's also one of my part of my background. And so we have a small pull request in async way of working, and on the other side we have pair programming and mob programming, which are co-creation patterns, as I call them. But how do we bridge these two worlds, right? Because, okay, we're moving on the spectrums, reducing the size of the PRs, but still we're working in async way. And I was trying to figure out, how do we compare these two kind of close things on the spectrum? And because I tend to get these also answers, we don't have to do pull requests because we already do small pull. We don't have to do pair and mob programming because we do already small pull requests. But what I got to see is that, and after lots of study, it made a lot of sense, is that as you decrease the size of the pull request, the average size of the pull request, you get higher engagement for the reasons that I mentioned. So there's a more systemic incentives to review sooner and to provide feedback. But on the other hand, the throughput of the system goes down. If you think of the system of how many changes through our system are we able to push in a unit of time. And so as you decrease the size of the pull request, the throughput and the flow efficiency being one of the metrics from Lean, we can talk about that as well, tends to go down exponentially, right? So the smaller pull requests that you have, and if you keep the same way of working in async code review manner with pull requests, the throughput of the system goes down. So you get higher quality, or preconditions for higher quality, because you have higher engagement on a small pull request, and you have lower throughput, right? And on the other side, with big pull requests, you have preconditions for lower quality, because with a big pull request, you're not even able to get the feedback for the systemic incentives that I mentioned, but you're able to push these changes through the system, right? Of course, you're going to have rework afterwards. Because, lack of quality and bugs and rework. But when you compare these two things, you notice then, okay, so we have to trade off between the speed and the quality, or the throughput and the quality, right? So on the small pull requests, you have lower throughput, higher quality. On the other side, you have the opposite. So that was an interesting thing to see, because I expect the pull request being better than smaller pull requests being in a way better than bigger pull requests, but didn't expect to see this plummeting of throughput.
Interesting. You would think that if with the bigger pull request, there would be the same interaction, right? If you actually take the time and review the lines, then it would make sense that smaller pull requests have that bigger throughput. But because the size of the pull request on a bigger pull request is just so big that you're like, well, it looks good to me, right? It's already too late either to build in that quality, or you'll course correct later, as you mentioned, but then you take a hit on quality, which makes sense then that the throughput for bigger pull requests is bigger. But also in my team, we noticed that, all right, I mean, big pull requests are not really reviewable in the first place. So we're going to do smaller batches, right? We're going to do faster feedback. We're going to fail faster. We're going to have that interaction back and forth, because code review is basically all about feedback, right? If you've missed a step, or if the quality is weird, or you implemented something in the wrong spot, someone can still course correct you, and you can still fix it, actually. But the thing is, you put your pull request up for review, and then you'll probably pick up something else, and then someone else needs to step out of their focus and work environment and review that piece of code. So that back and forth, even if you have to course correct, that might span over multiple days, which then makes sense that the throughput on the smaller pull requests is more than the bigger ones. But then because you still want to have that kind of quality check, right? You still want to do this and have that feedback as fast as possible. Is that then where kind of the co-creation patterns come in?
Yes. So the thing with the smaller pull requests, you can reduce the size of the pull request. You can have a bigger change that you slice it into smaller changes, right? But if you work in the async way, the thing here is, if you look at the wait time, like you look at the whole process, I have a visual for this, that, two developers, and they go back and forth in terms of the reviews and author and the reviewers, but they're busy with something else, right? So they're status review meetings, lunch breaks, outside of business hours, planning, daily stand-ups and stuff like that. Yeah. And people are not able to react immediately, right? So if you have a smaller pull request and I have a 10 lines of code change, if I need to wait 3 hours to get a review for this feedback, then the system is incentivizing me, because the transaction cost is really high. So maybe these 10 lines took you half an hour to develop, let's say, but you're waiting 3 hours, then this wait time is signaling really huge transaction cost in the system, which is incentivizing authors to go back and slide into the bigger batches. Yeah. Because it doesn't make economic sense for me to, have a processing time, the effective time that I'm working on this thing, half an hour, and wait for the review 3 hours. Yeah. And that's where the throughput goes down, because when you think about the flow efficiency, one of the metrics from Lean, which says, you're trying to figure out how much of the time through a life cycle of this work item that is flowing through our system, you are spending working on it effectively, and how much of time is this item spending waiting for someone's attention. Yeah. Right. So this PR sitting there and waiting for some review or a reply to a comment or whatever, change in the code. Yeah. So, and the flow efficiency says, okay, percentual wise, how much in the lead time of this work item do we have a processing time, which is effective working on this item. Right? Yeah. And with the smaller pull requests, when you think about it, the flow efficiency actually goes down. So that's the part of the study that I did, measuring the wait time, which is the thing that kind of helped me understand this, is that the wait time per line of code goes exponentially up as we decrease the size of the pull request. So the idea is that if you decrease the size of the pull request, the reviewers, people that are involved in this process and author, have to react exponentially faster in order for you to not lose the flow efficiency and throughput, right? So that means as I'm creating smaller changes, I need a faster feedback from the peers, but they're not available. The cost of this lack of availability is getting higher and higher as you decrease the size of the PR. Yeah, if that makes sense, right? Exactly. So let's see. So and there's also this thing about the processing time. When you work on this item, you are only dependent on yourself mostly, right? Yeah. So you don't have dependencies to other people, but the review part is including dependencies, and the cost of dependencies is really huge as you decrease the size of the PR, because this part is super important for the lead time. So that's the reason, like, this wait to processing time ratio goes up exponentially as we decrease the size of the PR, if we keep async way of working, async code reviews way of working, right? Yeah. And that was really interesting for me, because I tend to have this quote which says that ideal size of pull request is 1 line of code that is reviewed immediately, which actually tries to bridge these two worlds of co-creation, pair and mob programming, which is in sync, immediate feedback, And not only it's timely, immediate feedback after every line of code, but it's provided through a medium which is way richer than what we get with the async code reviews, communicating through some online tool where I have to write a comment. I have to write it down.
Yeah.
So compared to the verbal feedback that I get, which is throughput of the verbal feedback is way higher, just like in terms of the number of words. I'm not saying, on the side also the amount of, facial expressions and mimics that you're able to get, right? So the bandwidth is really higher. So it really shortens this feedback loop compared to the other way of working. So you get both immediate feedback, so it's a low latency feedback, and also high throughput feedback because it's a verbal one. So it was really interesting to then map this world that we have and seeing this data with the pair and mob programming. I didn't run this experiment with the teams that do pair and mob programming, but by default, it's impossible if you're doing pair and mob programming, it's impossible to have a wait time.
Yeah.
It's not a wait time of 3 hours and we're not pairing, right?
Exactly. Yeah.
So then the results were at least a couple of magnitudes better, both when it comes to the feedback. So the wait time is 0, right? Yeah. And because the wait time is 0, the wait to processing time and the flow efficiency, so the wait to the processing time doesn't grow exponentially, and flow efficiency and throughput don't plummet exponentially, but it stays the same. Plus, you're also enabling even higher bandwidth of the throughput of the feedback that you're able to provide, because now you have also both timely feedback and the feedback that is verbal one.
Yeah.
So that's what I saw, how these two roles map in a sense. So what you're able to have is both high throughput, the one that you get with arguably with bigger pull requests, because there's lots of free work that is waiting afterwards. And you're also able to have really high bar for and the preconditions for having high quality because of both timely feedback and the high throughput feedback, the verbal one. So
yeah. So if you're co-creating with someone, either it can be mob program or it could be pair programming. Do you then still submit the work for review, or not necessarily because you've already done that with a peer? So then you just pull it through. Is that what you mean with the lower throughput?
So when it comes to this, it really depends on the teams. In particular, some teams have policy, at least 2 people need to review the work. If that's the case, then what I suggest is all of these 3 people sit together and then they mob on this work item. Because if you're doing partially pairing and then waiting for someone 3 hours, it's the system incentive is still to increase the batch size. Because if I need to rename a method and wait for it 3 hours to be approved, then I'm not going to rename a method. Right. Because of this high cost. So what I'm trying to say is let's collapse these dependencies in a time manner. And let's try to work together on this. And but if you ask me about the XP environments, XP practices continuous integration, or I would call it true continuous integration, because the word has been overloaded so much. So right, and if you go back to the original definition, which came from, at least to my knowledge, from Ken Beck's work in the first XP project with C3 in 1996, C3 project, then you're going to see that the idea is actually to continuously integrate. It's not to have delays. If your pull request is taking more than a day to merge, then most probably you're not doing continuous integration. There's also this CI certification. It's kind of partially joke, but partially true. And it's coming, I think, from Just Humble. I think it's the article is also on Martin Fowler's website. But the idea is if you're not merging, from start of your changes until the merge to the main, it takes more than 24 hours. You're not doing continuous integration, right? So the idea, trying these time blocks in order to continuously integrate and have this new work on the main branch, so you're also able to enable continuous delivery, right, which is a really connected topic. But with the XP teams, usually they pair and mob, and they are, because they don't have any other dependencies. They also have really short feedback loop when it comes to the tests and regression testing. The TDD helps with this a lot. Then all the preconditions are there to push this immediately to main. So you don't have, branching strategies or Git flow or GitHub flow, etc., and waiting for dependencies, going back and forth and juggling 5 things at the same time because you work on this item, and then you're waiting for 3 hours, and then you're switching to something else. And because of that, also the working process inside of system is going up. And from Little's law and queuing theory, it says that if working process is going up, then the cycle time goes up as well, and the throughput goes down.
Yeah.
So you're just loading the system with more work and getting it to a stage where it's getting slower and slower. Instead of that, there's also this other world or parallel universe still in our industry, I would say, where you get to do these things way faster.
Yeah, that makes sense. I mean, if you see it as kind of overhead, right, and your wait time increases exponentially, you also have to, I don't think anyone's going to sit idle and wait for that pull request to be reviewed. So they're probably going to pick up something else. And that context switch, right? Not a lot of people can multitask very well. Actually, we're not great at multitasking at all, even though we think we are. So you have to context switch constantly, right? Back and forth. If you get a remark, you have to fix that, go back to the initial thing you're working on. Those are all context switches, as well as the other daily tasks or meetings that you have, or even rituals like stand-ups and refinements and stuff like that. Those are already inherent context switches. And if you want to be effective and be productive, you want to have as least of context switches as possible. That's why I'm very fond of kind of the co-creation patterns in the first place, except it's sometimes pretty hard to sell, right? Because if you're, let's say, pair programming, not necessarily mob, we'll cover that one in a bit, but it's 2 people working on the same thing, right? And you can say, well, the quality is going to be inherently there because you're going to have that back and forth, right? That feedback is going to be instant because it's just going to be a conversation. And you can even pick up on kind of nonverbal communication, like, It can be like, well, is this weird? Or you can discuss the options on the fly, but it's still kind of 2 people working at the same time on maybe one assignment. That's how I feel like most people view it. What are kind of the other benefits of pair programming that you've seen?
So that's kind of the reason why I actually got into this study, because I got to hear lots of these arguments, which I think are valid, to ask. But I think the way that we look at it is not necessarily the angle that we should have. Yeah. So that's the reason why I'm saying, if you look just through how fast am I able to type this code and then, push it to GitHub pull request and wait for someone to review. Yeah. So this is not the time span that we should be looking at. The time span that we should be looking at is the late time since the start of working on this item until we have it in production or to the customer. So whatever we choose. Yeah. But having this very, narrow way of looking, just cherry picking a timeline, time span, which is really short, to for this argument, that's not really something that we're looking for. So if you look at the whole lead time, you're going to figure out that you're way faster with pair and mob programming than with the async code reviews for the reasons that I mentioned, because the wait time is 0, throughput is so the throughput is high, and also the quality goes up, right? So less amount of free work, which is also feeding back into the system with the low quality work, right? For the teams that have lots of outages and working outside of their, like, so to say, regular work hours. So I think it's important to frame the conversations in the right way to figure out, what are we actually looking for? So what's the outcome that we want to achieve? Yeah. And instead of cherry picking just a single part, small narrow part of the timeline through whole lead time and thinking that this is something that tells us that we're faster. Yeah. I wouldn't say that that's really the case. But when it comes to the other benefits of co-creation, of pair and mob programming, it's really important to have in mind, especially in a remote world setting, which I think, as we know, most of the companies have moved or are moving effectively to, is that you get to lose so much of this emergent behavior that you get to have in-person communication in the offices, right?
Yeah.
You're not really able to bump into someone like, on a Zoom meeting, like I'm scrolling through a Zoom, I just found some Zoom link and someone is sitting there and saying,
Exactly.
hey, okay, are you up for a virtual coffee or not, right?
Yeah.
So you lose so much of this emergent behavior that serves as a building block or like gluing the teams that with the remote setting, that is really important to build this muscle. And I find it really important. I like talking about the pair and mob programming. These mechanisms really allow for all of these, or for lots of these conversations to happen, and for people to have a face-to-face conversation, right? Instead of communicating through some online tool, Slack, and you just communicate to a avatar that you see there, right?
Yeah.
So we're losing so much of this throughput of in terms of the human connection by going async, right? If you go more in sync, we get to have these preconditions for I would say higher psychological safety, building the trust in the team, and building the so to say acceptance and vulnerability inside of teams. Why? Because with pull requests, you're going to see only the end result of someone's work.
Yeah.
They could have made like thousands of errors in the meantime while they were typing or trying to figure out something, but you're not able to see that, right? With pair and mob programming, you're able to see all of these things. So it requires certain levels of psychological safety inside of a team, right? But there's a reinforcing feedback loop there, which says that, from my experience, the teams that pair and mob actually have higher levels of psychological safety, because the mechanisms of co-creation enables them to have higher levels of psychological safety, trust, and vulnerability, right? So if someone is able to see me make all of the mistakes that I make while coding, they also feel more comfortable making mistakes themselves, right? So it builds this vulnerability and acceptance, and helps a lot with the psychological safety and building team cohesion. And as you know, I think even still up today, the biggest research that has been done in Google to productivity of the teams is the, I think, Aristotle project, which says, and the results of those was the biggest factor contributing to the psychological safety, as to the high-performing organizations and the teams, is psychological safety, right?
Yeah.
So that's one more reasons why it's really interesting to take this into account.
Yeah, I never looked at it like that, but you're completely right? As a pull request, you just see the end result. You don't see any of the thinking steps that go in between, any of the errors that were made. Some people even force push and just overwrite the changes they've made to make it seem like it's perfect, right? Or at least good enough to be merged, because that's kind of the entire point of a pull request, is to make the quality high enough for it then to be merged and delivered to the customer or the end user, basically. Usually that's kind of the point of view that you get when reviewing, which makes it seem like, man, that looks good, right? And that means that person kind of figured this out on the fly. You never think about the kind of errors or thinking steps they've gone through. That's why I love why you mentioned in co-creation, you do see that, right? You do see some of the errors, even the ways of working, and both of those are things that you can learn from. And it completely makes sense that it would also then increase the psychological safety there, because you can see that you're just the same as the other person sitting next to you, because they also make errors, right? They also have thinking steps they go through. Makes them so much more relatable in that way.
Exactly. Just imagine, how much of comfort does this bring to someone who has less experience than you have, right? Yeah. Seeing you make all of these mistakes, right? And helping you also learn, how do you navigate this? How do you make incremental changes? How do you go about the work, from step to step, right? I'm not able to see this as a junior inside of a team. Plus, it's the amount of knowledge sharing that it's accelerated to the max. There's this saying in XP, and actually the way that XP was kind of thought of in the start is Ken Beck was talking about. The teams that he was working with figured out that there are some things that tend to be very important, and they turn the knobs on these things to 11. I mean, that's also the reason why it's called extreme programming. So, the amount of knowledge sharing that you have in the co-creation is turned to the 11.
Yeah.
Because the information spreads so quickly that you have, like, just in terms of the mental model, you have it takes you less time to achieve the eventual consistency. It's almost a strong consistency, like when you think about the mental models, right? With the async way of working, you're always lagging behind someone, and that's like this huge distances, like in the understanding, right? Whether it is code or domain knowledge or whatever. And and this is really, I find it really important. Like if you look at the Accelerate and the Dora research, there are these 4 famous metrics there, right? And one of the metrics is mean time to recover, right? There are other metrics which are change failure rate, which tends to go down as well because with co-creation, because you build the things with a higher quality and faster. The lead time to changes also goes down because the wait time is collapsed to 0, right? But then there are these other sets of the metrics. Or actually mean time to recover and change failure rate are part of the stability metrics, right? Deployment frequency and lead time to change are the parts of the throughput metrics, right? The tempo. And both these metrics tend to go up by default through, you don't have to do anything. It's like a byproduct of the way of working. And with the mean time to recover, it's really interesting. The teams that pair and mob actually have also, I would predict, I don't have a data on this, but I would predict that they have lower mean time to recover. Why? Because the mental model is shared across the team very fast. So if there's incident that happens, more people have the knowledge of the details of this working, so they're able to contribute to resolving the incident. So the mental model, shared mental model, is helping to drive the mean time to recover down.
Exactly, because they were all part of that while co-creating. They kind of shared that mental model in creating the things that they've created. So when something breaks, everyone already has that shared understanding, right? What we do now is when someone kind of delivers a big chunk of work, if it's with regards to billing, that's the person that made it, you should probably ask him. Or he needs to kind of, do some knowledge sharing sessions in the way that they built it or the way that it functions now to get the knowledge of the other team members up to par. But if you don't do that, then you kind of become the owner of that domain that you've built.
Exactly. And it's very difficult to get out of this reinforcing feedback loop because the more I am into this part of the code base, the more I'm going to be asked to be only part of this code base. Right. If I have an incident, I'm going to be the one. So I'm going to be exposed to more learnings to this part of the system, and others are becoming more and more distant to this knowledge that I have, that I accumulated over time, right? So that's also one important thing to have in mind, because collective code ownership is something we try to strive for, right? But with this way of working, that's kind of getting farther and farther away from us. And on the other hand, also thinking about the system incentives that have been set up with the async code reviews, you have author and you have reviewer, right? So you have author and you have potential critic that can think about finding a value in their role of trying to find mistakes, right? And the incentives with the co-creation are completely different. All of us are authors of this, both authors and critics, right? So these system incentives are way more aligned to make this thing work rather than just fulfilling our roles, right? You can also think about it in the very traditional teams with a QA engineer going after developers and testing the software, regression testing, manual or whatever, and the system incentives there are completely out of line, right? And you have all of these subsequent dysfunctional behavior that you get because of the misaligned incentives there. So thinking about aligning the incentives to the ways of working is hugely important.
It sounds essential. And it seems so relatable to me because I don't come from a software engineering background, right? I had some data science courses at university, but I switched from operations to being a developer. And I still remember kind of the first pull request I put up. I was pretty proud of that until it got like 40 comments on things I didn't see or the options I didn't even weigh out, or I just got it done because this was my first pull request. So then I had to rework it, and it must have taken a few days for me to get that work in, basically. And I did think, man, either these people are very critical, or this is just the quality we strive, or they're perfect because, I mean, they're the ones that are criticizing, right? And after you do that a few times, you're like, okay, it's all about getting that feedback faster, right? As you mentioned, smaller batches of pull requests. But that feedback is still back and forth, right? The same context switches we talked about. Until you actually go up to a person and then you start discussing the options that you have in your head, right? And they can give you that immediate feedback loop. It's not necessarily pair programming, but you just walk up to someone to get that feedback sooner than within a pull request, right? That's not really async in a way. It's also not really pair programming. And now I like that you say with pair programming, there's so much byproduct, right? The psychological safety, the co-ownership of a mental model, like so many benefits that you already do while doing the work together. It sounds like kind of the missing piece of the puzzle. I would like to see some studies in comparison in that way. But then would you also suggest that it's all of the work that you do in kind of a pair or more programming setting, or just some of the work, right? Because I can imagine if I need to do a config change, a second pair of eyes would help, but that could still go through kind of a pull request. I don't know if it should be all of the work. And also I think the people involved, do they need to, how do you say it? I had Dennis Doma on a very early episode, and he says, I'm just not the type of person to pair up with someone. My brain doesn't really work like that. And I wonder if it's because he's saying that, or he hasn't experienced that, or it's not for everyone. I still kind of torn between those two.
So those are really important questions that I tend to hear very often. So when it comes to the first question, I don't think that pairing and mobbing all the time is the thing that we're looking for. But the problem that I tend to see with teams that don't pair and mob at all is, let's try pair and mobbing and see where it's applicable.
Yeah.
And because of the mindset that they have, that has been created and shaped by the way of working that they're currently working, they're not able to find the moments where they think they should pair and mob.
Yeah.
It's very hard for them because this muscle hasn't been developed in the cognitive way, so to say, when it comes to ways of working, right?
Yeah.
So for me, it's kind of interesting. What if we switch the way around it, right? So let's say that we pair and mob most of the time, and we find good reasons for not pairing and mobbing.
Yeah.
Right? So we go from, not pairing 90% pairing 10% and not pairing or mobbing 90% to, let's say, 80% of pairing and mobbing and 20% of not mobbing, right?
Yeah, you turn it around.
Exactly, yeah. And so it's not like 100% because I don't think that you should or need to pair full time all the time. But I think 80 or 90% trying to start from this point and seeing how this enabling constraint shapes the way that you think, and realizing uncovering all of these points that we've been talking about in this new world is really important for the shaping, so to say, the mind in a sense, right? I really have this interesting because I think it's a really important enabling constraint, and I tend to love enabling constraint or forcing functions to help us build the muscles that we were not by the way that we live or work or talk or think currently are not able to build, right? So that's kind of on the first point. On the second point, I think it's important. So I'm introvert myself as well, but I enjoy pairing and mobbing, right? So there have been some episodes with Mob Mentality Show, which I highly recommend. And they have been also talking a lot on these points. And there's also, so I don't think it's kind of exclusive for extroverts in a sense, right? This way of working. That's one thing, and the other thing is also I'm really curious to understand, because we are so much used to this way of working with the async code reviews and working in silos individually. I would say not working as a team, because for me the team is precondition for a team is high levels of trust that has been built also through the ways of working. That because we have been so much in this async isolated world that our thinking has been shaped by it as well. So we strive more to something that is familiar to us and and label it as more comfortable, right? So pairing and mobbing are skills. They have to be learned. It's not something that you just wait, go out of bed and say, okay, now I'm going to do this perfectly, right? There are some skills, because the other thing also that I find interesting is that the teams. So I'm jumping from topic. Sorry about that, but they have all these really related points that I think help to craft the whole picture. Is that when you think? So I lost my thread. But when you think about the pairing and mobbing, it's a skill, right? And when teams get to work together, right? When I say work together, I mean co-create. You tend to understand how much of different thinkings are in the team, but they haven't had a mechanism to surface it. And suddenly you're seeing lots of clashes. This person optimizes for this thing, the other person optimizes and values the other things. But the problem is not pairing and mobbing, right? These are just the mechanisms that helped us to elevate and surface these different philosophies or different cultures inside of a team, right? And we haven't had a chance to really look at them because we weren't able to do it through the current way of working. We were able still to be kept isolated from one another. So that's also important to have in mind when starting this journey of co-creation, that you're going to have some rough road until you really align as a team, like what are the things, and you get to understand how other people think and work, right? So it's kind of very subtle point, like hitting this point of I'm not the person to do this. I also try to think about, is it because you're really not, or maybe also the way of our way of working also shaped our mind. But, so I advise to try it, experiment for so give it a time, a couple of weeks, so to say, or I don't know, month or two, and see after that. It can also be. I'm also up for, or can completely understand if really someone is saying, okay, this is not my cup of tea, and that's good to know as well. Good to know for that person, and good to know for the team.
I really like the analogy of kind of a muscle, right? You don't just start up from nothing and start running. You're going to be out of breath first of all, and the next day you're going to be very sore, right? So kind of building up that muscle of co-creation is very important. And as you mentioned, we don't really do that by default, right? The default right now is that asynchronous work pattern. So I would like to see if we do that a bunch of times, you probably get better at it. And the thing you mentioned also, very relatable to on my end as well, in kind of the different mindsets. Maybe it's not mindset, but even implementations that someone can go through, right? The most obvious one to me is being practical versus thinking about the future, right? You can already implement a bunch of things that you might need in the future, or you can just go straight ahead and do the practical implementations. Both are going to have pros and cons depending on your use case, but you're only going to see that end result, right? And if you're there while you're co-creating, you can challenge that. You can be like, is this kind of the right way to do it in this current use case? Or should we do the practical one? Or should we think about these instances that we might have in the future? Or actually, we will have one of them. So should we implement it now versus later? That can be a dialogue. And it's not necessarily a dialogue in a pull request. It might be a criticism, as you mentioned. And it will then be at the very end, basically, while it's already too late. Very interesting.
It's like we are setting up system in a way that reduces the cost of these conversations emerging. And this is something that we really want to have. Because if the way that we have set up our system and ways of working is incurring huge costs, transaction costs for these communications to happen, they're not going to happen.
Exactly.
On average, they're not going to happen. So I love Deming's work, and he said that 95% of the behavior is governed by the system. So on 5% you can try to beat the system, but 95 times out of 100, of course, the numbers, I'm sure not super accurate, but the point is something different, that the system drives the behavior, and on average, you're going to have the behavior that the system dictates. So that's the reason for, that's the way that I imagine the role of people working in the system, and especially thinking about the management is designing the system and the environment in which people work and the way that they interact in order to, for us as a whole team to have personal satisfaction and achieve the outcomes that we want to achieve, from the business perspective, but also like on the personal and relationship level, right?
Exactly. Just to be happy and productive, right? If you're productive in what you're doing, if you're actually delivering that value, that you're going to be happy because of that. And if you can make someone else happy, you're going to be even happier, right? And if the system incentivizes that and makes it more effective, then it's a great system to be part of. Kind of as a final question I have is, I could see kind of pair programming working very effectively also in a non-remote situation. But because we're now moving more and more to remote, do you think it's as effective? Because someone can share their screen, we can jump in a call, I can still kind of figure out their thought patterns as we go. The only thing I don't have is that non-verbal communication that you would have otherwise.
Yes, you're losing a bit of the bandwidth of the throughput of the feedback that you're able to get, right, in person communication. But that's the reason why, like, for example, using, Zoom as a default tool when sharing the screen. So when I share the screen with the code, I'm able to see the other person as well, right? If you use Google Meet, I'm not able to see the other person, right? So these are really simple, small things, but they can have a huge leverage, so to say. And effect. But when it comes to this question, I think it's even more important to try to nurture this for the reason that I mentioned before, because with the remote work, we lost all of the emergent behavior that we used to have in office, right? Telling jokes, going together for a coffee, taking breaks, going for lunch, all of these side conversations that happen that help to build the cohesion and trust and psychological safety in a team. So I think, like, going remote, it's even more important to go to try out or to utilize these co-creation patterns, because they keep the team together in these times as well. The thing that I noticed in industry, which is, I would say, not a good thing to have, is that remote work has been associated with the async. So if it means remote, that means we're async. But that hasn't to be doesn't need to be the case, and actually shouldn't be the case for the reasons that we also talked about in the start, because of the throughput and all of these systemic incentives that have been set up as there. So I find it even as a stronger argument even for considering these options, because again, we lost so much of the things that made us a team. Yeah, that makes sense. I'm going to experiment in kind of doing it through Google Meets or through Zoom, where I can actually see the person versus I cannot. I really like it. Man, lots to think about. I was already a fan of kind of the co-creation patterns, and we didn't really touch upon mob programming, but I think we just need to do, at least within my team, I just want to do more and experiment more with it, because the things you've laid out, the benefits, are pretty huge to me, at least. So I want to thank you for coming on, Dragan. I learned a lot, and I had a lot of fun. I hope you did too, or enjoyed it as well. Yeah, I enjoyed it a lot, and thanks again for having me. Cool, man. No problem. Dragan Stepanović, everyone.
Beyond coding. From your sponsors, Zebia, creating digital leaders.